Something entered our solar system quietly, bypassing any fanfare. It didn't shine brightly or make noise, just appeared. Fast, silent, and exact. Initially, it resembled any distant icy rock, just another fleeting blur in vast deep space. However, as telescopes observed it longer, its behavior became increasingly peculiar. Now, it's been named 3I Atlas. Its final transmission stunned scientists, for what follows is anything but ordinary. It challenges how we perceive the sky above. Atlas first came to attention in June through survey telescopes, barely a blip on their radar. It was distant, dim, and on a steep hyperbolic trajectory, the signature of an interstellar visitor. Only 2 such objects had been documented before, leaving profound impacts on both science and imagination. Yet, Atlas continued to surprise us. Analysis of archival images revealed it had passed before, cutting through years of data with a perplexing path. Its velocity was shocking, much faster than expected for an object drifting through interstellar space, and troublingly, it showed signs of non-gravitational acceleration. Simply put, something was influencing its movement, in ways we cannot yet comprehend. This revelation caught the attention of experts in the field. Non-gravitational forces could arise from phenomena like outgassing, as seen with comets. However, Atlas did not act like a standard comet. It was much too bright for its expected mass, reflecting light as if polished. Unlike a tumbling rock, it moved with an almost calculated stability. Questions mounted. What is it composed of, and who orchestrated its movement? Scientists turned to the James Webb Space Telescope, the most advanced observational instrument we've developed. The task was to investigate this enigmatic visitor and discover its true nature. The findings were, to say the least, strange. Atlas didn't display the expected thermal profile associated with comets or inert rocks. Certain spectral bands were absent, implying that some materials were either absorbing infrared or cloaking their emissions. Furthermore, Webb and other observatories detected a faint, structured radio pattern, an anomaly pulsing in a way that felt too patterned to be mere cosmic noise. Research labs in Japan and France analyzed the timing of these pulses and identified repeating intervals, mathematical patterns woven through the ambient silence. The intervals reflected prime numbers and Fibonacci sequences. Strikingly, some timing ratios resembled orbital harmonics found within our own solar system, specifically resonances like those of Jupiter's moons. The reasons for this object's encoding of a pattern so closely aligned with our planetary dynamics eludes simple explanation. Infrared images collected over subsequent weeks revealed another bizarre characteristic. Atlas was not just fluctuating in brightness, its apparent structure was shifting. Surface features changed orientation, reflecting light differently, too organized for a mere tumbling boulder. A reconstruction from a group at Caltech proposed a disturbing possibility. Atlas may not be a solid object. It could be composed of extraordinarily thin materials, akin to a massive solar sail, capable of altering its orientation and effective surface area in response to radiation pressure. In this context, traditional propulsion might not be necessary, the stars themselves could provide the thrust. Then, the online community began to buzz. Public telescope feeds suddenly became quiet. A university live tracker led to a dead link. Amateur observation forums faced unexpected bans. Researchers noticed patterns of censorship and whispered about coordinated efforts that seemed unusually deliberate. Scientists speaking off the record revealed they were advised against speculation. Official statements remained composed, tracking is ongoing, no public information forthcoming, but discussions in labs shifted. Some referred to it as containment, while others labeled it precaution. During this unfolding situation, trajectory models indicated Atlas was moving inward rather than outward, altering its course in ways gravity alone could not explain. Close encounters with Mars and the inner solar system were calculated, not as collisions, but as deliberate passes, close enough to observe and analyze. The object is projected to make its nearest approach to Earth's orbital path in December. We won't face a collision, at least not with the central mass. However, concerns lie elsewhere. A slow, calculated survey that aims to explore rather than threaten. Embedded in a quickly downloaded supplemental dataset, before files vanished, was a spectral anomaly that raised significant alarms. Some researchers highlighted an isotope signature that is nearly unknown outside advanced fusion studies, pointing to something that should not exist in deep space. If validated through peer review, this finding suggests technology or processes that far surpass natural formation. Our models may be fundamentally flawed, or this object might bear the signs of engineering. Consider the first mysterious visitor years ago. Oumuamua appeared and vanished in silence. While some speculated, most remained skeptical. In contrast, Atlas is more distinct, not a loud announcement but a thoughtful series of signals. It communicates in patterns rather than straightforward language, structured enough to demand scrutiny, ambiguous enough to provoke debate. Some within the SETI community indicate that internal records suggested signals months before Webb's images were released. The choice not to make this public breeds tension. Others advocate for caution. Refrain from asserting contact until all mundane explanations have been ruled out.